Okay, so this is 6.2 and it is over one-to-one functions. So let's go ahead and get started on this. Okay, so on these, remember if we have a function, we cannot have any repeating domain. So on a one-to-one function, for every domain value, we have one range value, but for every range value, we now have one domain value. So for every x value, there's one y value. That's still not it. For every y value, there's one x value. So nothing can be repeating on one-to-one functions. So this first one, we have Sean, Jeff, Scott, and Alex, and then our ranges Susan, Mary, and Kathleen. Scott and Alex both go to Kathleen. So since Kathleen has two domain values, this would not be one-to-one. We'd need another person here. So this would be no. Here, the exact same problem. So it's still no. I have an example of one that's one-to-one. And I'll put this with it. So here, since we had our domain, and for every domain there was one range value, for every range value there was one domain value, so this would be considered one-to-one. Here, for every domain value there's one range value, for every range value there's one domain value, so this would also be one-to-one, where both of them on this paper were not one-to-one. So here, for the following function, determine whether the function is one-to-one. So we have 4, 3, -7, and 1. So we have no repeating x values, but then we have 6, 6, 3, and -5. So we have a repeating y value. And since we have that repeating y value, this would not be considered a one-to-one function. Why are all of these no? For the function below, determine whether the function is one-to-one. So 7, 8, 9, 10. No repeating x values, 7, 8, 24, 81. So no repeating y values. So this one would actually be a one-to-one function. So if you remember the vertical line test before, where we determined if a function, if a graph is of a function, because our vertical line would only cross it one time. Now for the one-to-one function, they have a horizontal line test. So that means if we draw our horizontal line and only touch the graph once, it's one-to-one. So this passes the vertical to be a function and the horizontal to be a one-to-one. So this one would be yes. Here, if we did our vertical line test, we're only going to cross once, so it is a function. Then if we do our horizontal line test, we'd cross this graph twice, so it would not be a one-to-one. 7, the graph, so vertical line test, it is a function. Horizontal, it only crosses it once, so this one would be a one-to-one function. Burning through these. The graph of a one-to-one function is given. Draw the graph of the inverse for convenience, and as a hint, the graph of y equals x is also given. So on these, when we do an inverse, we're switching our x and y values. So if I had -5, -5, and I reverse them, it'd still be -5, -5. But here, I have -5 and 0, so -4 and 0. So when I reverse them, I'd have 0 and -4. Here, 1, 2, so I'd have 2, 1. 2, 5, so I'd have 2, 3, 4, 5, 2. And then if I drew that graph, it's going to mirror across this y equals x line. So keep that in mind. So our graph that matches this would be here. The graph of a one-to-one function is shown to the right. Draw the inverse. So what we just saw is that our inverse is going to be mirrored across this y equals x. So we have -3, -3, that would still be there. And then we'd have a point here-ish for something that looks like that. So we're going to have C, our squid. Consider the function f of x equals negative 7x plus 7, g of x equals negative 1/7 times x subtract 7. What is f of g of x? So this is the same as our composite functions. So it's the same as it being wrote like this. This is just another notation. So let's go ahead and do that. So I'm going to substitute the g function into my f function. So I have negative 7 times negative 1/7 x subtract 7, and that was all the g. So I'll close that and add 7 on the outside. So negative 7 times negative 1/7, a negative times a negative is positive, and then 7 divided by 7 would be 1. So we're going to be left with our x subtract 7 here. Add 7, negative 7 plus 7 would be 0. So we're left with just x. So f of g of x equals x. And then they ask if, what is the domain, any values of x that need to be excluded. Since there's nothing in this, either of these functions that are going to make it undefined or unreal, there's no values that should be excluded. Now then we're doing g of f of x. So we're going to take our g functions, so negative 1/7. Instead of x, we're going to put in our f function, so negative 7x plus 7, and then subtract 7 to finish our g. So combine our like terms right here. Positive 7 subtract 7 would be 0. So we're left with negative 1/7 times negative 7x. Negative times a negative is positive. 7 divided by 7 is 1. So we're left with positive x. And then are there any values of x that need to be excluded? There's nothing that's going to make this undefined or unreal. So no values should be excluded. And then are the functions f and g inverses of each other? Yes. Because they both equal x. Yes, because they are equal or the same. Either way you want to say that one. Okay, show y'all that full screen real quick. Okay. 11, it's the same type of problem, just different functions. So we have, what is f of g of x? So we're going to take our f function, so 4, and then where it says x, we're going to substitute this g function in, so x divided by 4 plus 2, and then finish out our f function, subtract 8. So we're going to distribute this 4 in here, so 4 divided by 4 would leave us with x here. 4 times 2 is 8. 8 subtract 8 would be 0, so we are left with x. Is there anything that needs to be excluded? There's nothing that's going to make this unreal or undefined, so no value should be excluded. Now we have g of f of x, so we're going to take our g function. So we're going to substitute f in for this x here, so we have 4x subtract 8, all divided by 4, plus 2. So we're going to go ahead and divide here. 4 divided by 4 is 1. Negative 8 divided by 4 would be negative 2. Add 2. Negative 2 plus 2 is 0. So we're left with x here. Is there anything that needs to be excluded? Only thing we're dividing by here is 4, and that's not going to be unreal or undefined, so no value should be excluded. Both of them equal x, so they are inverses. Yes, because they are equal. Okay, I'm going to start a new video for these next 4 problems. So let's stop this one.